I started with any function, and I put that symbol beside it. This is the integration. And then I put an interval from 0 to 1. And then I tried to figure out what function, if I differentiate it, will give me back this one. So 1, if I differentiate x, it will give me back 1. And if I differentiate x cubed over 3, it will give me x squared. And then I took that new function and evaluated it at the end of the interval and at the beginning of the interval. I subtracted these two values and ended up with a value. There is no C here. Where is C?
Subtracted.
This is a definite integral. Okay? This is a definite integral. Just, did you follow the steps? Each step by itself. Does it make sense? Yes? Okay. Now let's look what is this is equivalent to. This is the curve y is equal to 1 minus x squared. From 0 to 1. Y is equal to 1 minus x squared from 0 to 1. And the area that I want to estimate is this blue area over here. How would you calculate this area? If there is like some formula, have the height times the base, if there is something like that? No. Any curve in general, you do not have a formula to estimate the area enclosed in that curve. Very, very small number of curves. Very, very small number of curves that you have actually a formula for it. Like the circle, ellipse, very, very small subset of all the curves that you can think about. Good. So what I can do to approximate this area, I can divide it into rectangles. So if I take that interval from 0 to 1 and have it into two intervals. One is from 0 to 0.5 and the other one is from 0.5 to 1. This is a rectangle, this is another rectangle. What is the height of the first one? The height of the first one is f of x at x is equal to 0.5. Okay? And the height of x at the beginning of that interval. And the height of the second one is f of x at x is equal to 0.5. So the first one is 0 and 1. The second one is 1/2 and 3/4. The area of that rectangle equals 0.5 times 1. The area of that rectangle is equal to 0.5 times 3/4. What is the error in my estimate? I have two rectangles, I added them, I ended up with an area. What is the error in my estimate for that area? What color? Pink. Okay? So pink here, this is the error. If I take finer steps, if I take smaller steps, 0.25, 0.5, 0.75, and 1, and then I add these smaller rectangles, okay? Do you think that I'm getting closer to the actual value or farther away from it? Closer. Okay? And if I keep making these rectangles smaller and smaller,
The error will be
decreased smaller and smaller. At the end, I will reach this circle. الاريا بتاعت الريكتانجل ده اهو دي كام؟ واحد ودي نص. واحد في نص بكام؟ بنص. طيب دي كمان نص اهو في كام؟ 3/4. نص في 3/4 بكام؟ 3/8. في النص ده 3/8 يطلع كام؟ 7/8. يعني أنا estimating the area under this curve to be 7/8. Do the same here. Now 0.25 times 1 plus 0.25 times 15/16 plus 0.25 times 3/4 plus 0.25 times 716. Add, you will end up with another number. It's another approximation for the area, the blue one here. And the error is the pink one, because the error is not actually under the curve. Okay? Now, if, as opposed to taking the beginning of the interval, if I took the end of the interval, okay? Now I'm leaving out the blue areas. Okay? I'm leaving out the blue areas. Would this give me an estimate that is higher or lower?
Lower.
Lower. Always, the question is, if I take the beginning of the interval and the end of the interval, am I always getting higher than the area and lower than the area? In one case and the other case? Who would say yes, no? مين مش فاهم السؤال؟ 60 ليه؟ Again, the question was, if I have such kind of area, and then I'm taking these types of rectangles, okay? As opposed to these types of rectangles, okay? Okay, so if I'm taking these red ones versus these blue ones, am I guaranteed that the blue ones are always bigger? What about in this case? Let's take this one. Where is the red rectangle in that case? The red rectangle is here. Where is the blue one? The blue one is here. So if the function has this versus this, okay? So depending on the curvature of the function, this one can be overestimating the area and the other can be underestimating the area. واحد ممكن يكون الاريا اكبر والتاني ممكن يكون الاريا اصغر. طيب لو انا خدت في النص، لو انا خدت if I take it exactly down the middle as opposed to the beginning or the end. So I'm taking some blue and leaving some pink. Taking some blue, leaving some pink. Some blue, leaving some pink. Would this be a more accurate estimate? Yes. Okay. So, but what is the problem with doing this?
Calculations.
Look at this one. How many times did I have to evaluate f of x?
3.
I had to evaluate f of x here according to the number of divisions.
Yes.
So if I had 4 divisions, I need to calculate f of x 3 times. Okay? Now, here I'm evaluating f of x how many? 4 times. Okay? That's not a very huge penalty. So, again, the area of this rectangle would be 0.25 times 63 over 64. The area of this rectangle would be 0.25, the base, times the height. The height is what? F of x at the middle of that interval. The middle of that interval is 0.375. I evaluate f of x at the middle of that interval. Okay? And this would be the height of the rectangle. And this would be 0.625 and the 39 over 64 and so on. Let's look at some numbers to see where this is heading. So this one, if I'm taking 2, 4, 16, 50, 100, 1,000 subintervals. Of course, you would not do this by hand. You'll have a nice software like that one that you like, to do this for you. So the lower sum, the midpoint, and the upper sum. The lower sum, which is the smaller rectangles, give me 0.375. The midpoint gave me 0.68. The upper sum gave me 0.875. This is the 7/8 that we calculate, right? We calculate 7/8. This is the 7/8. If I have 4, this is 0.5, 0.67, 0.78. If I have 16, 0.63, 0.66, 0.69, and so on. Where this is heading 0.666667. Does this look what? Two-thirds? Where did we see 2/3 earlier today? The integration?
Yes.
مين شاف التين أول النهارده؟ كويس. When we actually did the set of steps that we were taking, the set of steps, the integration from A to B. ممكن عشان بس يبقى الثلاثة على طيب so I reached the number 2/3 in two different methods. Two different methods give me the same number. The first one, without looking at a curve or an area or anything, I took a function and so what function, if it was differentiated, it will give me back this function. And then you evaluate this function at the end of the interval and subtract this from that function at the end of the interval, and I got a number. And totally independently, I started doing area under this curve. I draw the curve 1 minus x squared. I divided it into smaller and smaller rectangles, and I ended up with this number. That means that the first method is equivalent to the second one. Is equivalent to the second one. Okay? If you understand this part, then that lecture becomes very simple. Area under the curve, definite integral. Area under the curve, evaluating the area under a specific curve, is equivalent to that process that we did at the beginning that's called definite integral. Why we call it definite? Because it has a beginning of the interval and the end of the interval. It does not have the plus c. There is no plus c. When you are doing a definite integral, there is no plus c. Yes, sir. Again, this is because let's go back and put it. This is 1 minus x squared. The integration of this is equal to x minus x cubed over 3 plus c. Right? Now, in order for me to evaluate the area from what? Minus infinity to infinity? From 0 to infinity? So I have a finite area to evaluate. Okay? So if I don't have any numbers here, this is an indefinite integral. If I have any numbers a and b, this is a definite integral, and it's evaluating the area between under this curve between at the interval a to b. Simple enough? Yes, sir. ليه؟ طيب. First of all, did you see that it's actually the same? Okay. So if I have the same two different processes that will take a function. If I have two different processes that will take a function and give me back the same number, I would say that these two processes are equivalent. The process of finding the area under the curve is equivalent to the process of definite integral.
يعني مثلا احنا بنعمل ليميت اللي هي اذا عملنا الليميت
بالظبط. If you keep getting smaller and smaller, smaller and smaller rectangles, it will approximate ultimately the exact area under that curve. So if I take that sum to be, instead of 1,000 that we just saw, if I take it to be 1,000,000, 0.666666, okay? So at the end, since dx represents a very small distance, it's very infinitesimal, small distance of the x-axis, then that process becomes from the summation to the integration.
يعني differentiation عشان كده
بس معلش فوق بس.
يعني differentiation عارف ان هو اخر زد ولا اخر اكس ماينس اخر زد على اكس ماينس زد. فاهم بتاع differentiation ان هو يجيب الاريا بتاع integration.
Okay. So far, you're with me? Wait a couple of slides. Let's talk about this summation. Let's talk about this summation. Who did not see that symbol before? This is called sigma. Sigma is the summation of a few or many or infinite number of terms. Sigma from k equals 1 to n a sub k. And a sub k is the formula for the kth term. And what we can do is that simply add. If you have 1 plus 2 plus 3 plus 4 plus 5, the value of that sum is equal to 15. فورة 70. طيب خلاص مش داعي خلاص هنتكلم. And each one of these cases, I am simply adding these terms. In some cases, I can find a formula to get that sum. Let's define. Let's talk about a specific case. I have sigma from k is equal to 1 to n for k. This is sigma. If I have for n is equal to 4, for example, this is sigma from k is equal to 1 to 4 for k, which is equal 1 plus 2 plus 3 plus 4. Okay, this is equal to, these two are 5, these two are 5, so this is equal to 10. What would be, how did I arrive at this? 5 is n plus 1. And how many 5s? 2. Okay? Now, let's see this in a different way. I have this What is this triangle? This is the summation that I just did.
Yes.
1 plus 2 plus 3 starts 4. The number of these dots. Then this is what I'm looking for. let's put some more dots. حصة ألوان النهارده. What is the area of this rectangle? How many? This is 1, 2, 3, 4, 5. How many? 1, 2, 3, 4. So this is 5 times 4 is equal to 20. How many red ones? Okay. What was this? Okay. What was this? So n plus 1 times n divided by 2. Yes. This is, so, now that you guys are clever, what is sigma from 1 to 100? 4 k. So, is this right or not right? So this is 101 times 50. Is that correct? So right now I have a formula to get the sum of k numbers. What about this one? 1 plus 3 plus 5 plus 7 plus 9, the odd numbers. Let's see, sigma n is equal to 1, k is equal to 1 to n, 2k minus 1. Okay? 2k minus 1. First of all, what is this? 1 plus 9 is what? 10. 3 plus 7 is 10. And 5 is 25, so this is 25. Okay? Now, can I write this as sigma from k equals 1 to n